Okay, welcome back, everybody. Your series of guest lecturers is going to start tomorrow, but today I wanted to do with you. And so, just for today, I made a video explaining our first topic, which, as I said in the last video, we're going to spend 2 days just talking about two-dimensional arrays. Um, this might be something you might want to take some notes on, so you might want to get out some paper. If it helps you to pause this video as I'm going through it, that would be fine. I will post this the entire PowerPoint presentation. In fact, it's already posted up on Schoology if you want to just use that as reference later on. So, I don't know, a little bit on two-dimensional arrays is where we're going to begin. So first of all, just think back to last semester when we talked a ton about arrays. Although I never used the term, you could think about an array as being like a one-dimensional array, a 1D array, because it only has a length, right? Going back to your geometry days, 2 dimensions would be like area. Every array we've done so far has just been a one-dimensional array because it's just so long. And just to remind you, here's how you declare an array. Nums is an array of 10 ints. If you want to access the 8th element at index 8, you would say nums bracket 8 equals 25. Okay. Although again, although I never used the term where we would call that a one-dimensional array, okay, or just a plain old array. So now on to the big new idea, which is a two-dimensional array. And a two-dimensional array is basically a grid. It's got rows and columns, and it's lots of situations where you might want to think about something being a two-dimensional array. Any graphic, sort of, is a two-dimensional array of pixels. Heck, your screen is a two-dimensional array of pixels. Lots of games, checkers, chess, tic-tac-toe, all involve a grid, which probably could be a two-dimensional array. You can imagine a spreadsheet is a two-dimensional array, a crossword puzzle is a two-dimensional array. Just grids tend to come up an awful lot in computer science, and so we're going to represent those as two-dimensional arrays. We're going to learn a lot about the syntax of two-dimensional arrays and do a little bit of some problem solving with it over the next, oh, my microphone fell, excuse me, over the next, couple days. So first of all, how do you declare a two-dimensional array? Well, a two-dimensional array, or a one-dimensional array, we just said int bracket bracket. Guess what? Now it's bracket 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 bracket. So this first bullet, int bracket 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 nums, nums is a two-dimensional array of ints. Looks very similar to an array, doesn't it? Which is an extra set of brackets. And then rather than saying new int bracket 3, now we have to specify both the kind of height and width. So we'll say new int bracket 3 bracket 4. That means that this nums is a two-dimensional array with 3 rows and 4 columns. The rows always come first, as we'll talk about later. Second bullet, you can make a two-dimensional array of anything. So I've got letters is a two-dimensional array of strings. String bracket 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 bracket. And then you can say new string. So this particular two-dimensional array has 25 rows and 20 columns. It might be like a Scrabble board or something like that. And then just like last semester where we made an array of some new type you've never seen before, look at the last bullet, chess piece bracket 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 bracket. Board, that's a two-dimensional array of chess pieces. And then I say equals new chess piece bracket 8 bracket 8. That would be a square two-dimensional array because it's the same number of rows and columns. That'd be an 8 by 8 two-dimensional array of chess pieces. And again, I did this in kind of in one line. You could split those up into the initialization and the declaration. You could say int bracket 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 nums semicolon, and then the next line you could say nums equals new int bracket whatever. Okay. So that's a little bit how you declare a two-dimensional array. And again, you might want to write this down, or I've got this PowerPoint up on Schoology if you want to use it for notes. How do you access one element? Well, you just need 2 brackets now. So look at that first line, nums bracket 1 bracket 2. That means you're in the first row. So see on the left-hand side where it says row index, your row index 1, and then you go over column index. So nums bracket 1 bracket 2 means row number 1, column number 2, and you'll see that there's a 9 in that spot. It's a little bit confusing because we normally think of it's always rows and columns. We think about which row you're in. Rows are horizontal. And so you think about this, shouldn't the first one control how far you are going in like the X direction? But that's not the way it is. Which row you're in means how far up and down you go, and which column you're in means how far right and left you go. So if you think about X and Y, it's sort of reversed if that helps you. If not, just think about it's which row you're in and which column you're in. Okay, so the second bullet says nums bracket 2 bracket 0. So that means you're in row number 2. That's the bottom row. And then you're in column number 0, and you see that there's a 3 in that box. And then the third bullet, nums bracket 0 bracket 2, you're in row number 0, column bracket 2, and then you can see there's a 5 in that particular box. Okay? And so just like you can do anything with an array, same thing here. You know, nums bracket I was sort of one element of an array. Nums bracket something is going to be one element of a two-dimensional array. We're going to obviously talk about how to loop through it and sort of everything else like that. Okay? It's always rows then columns though, both when you declare it and when you access a box. And that's a little bit tricky to remember, rows then columns. So the way almost all computer scientists remember this is with there's this old soda called RC Cola. And so when you're thinking RC Cola, that helps you remember it's rows and then columns. In fact, if you look at the right side of our classroom near the door, on top of the bookshelf, and there's some RC Cola. I leave those cans there to remind you about RC Cola. I think they're there. If not, someone took them. So RC Cola, RC Cola, RC Cola helps you remember that it's always rows and then columns. And again, a little bit tricky. Rows go right and left, and then columns go up and down. Columns going up and down I think makes sense because I think about Greek columns. But which row you're in is kind of in the Y direction, and which column you're in is sort of in the X direction. Okay? Nums bracket 1 bracket 2 means you're in row number 1, which means go down 1. And then column number 2 means you're in the third column, or in column number 2, so that means you go over to the right. Okay? We'll talk about RC Cola a lot. And my guest lecture tomorrow that'll take you through a big old two-dimensional array example. We'll probably refer to RC Cola. And if she doesn't, remind her about it. Okay, one thing that I just want to make a little bit clear, it doesn't come up a lot, but technically there's no such thing as a two-dimensional array. Technically, when we're talking about two-dimensional arrays, really what we're declaring is an array of arrays. Let me say that again. Really, a two-dimensional array is an array of arrays. So the picture really for a two-dimensional array is not technically a grid, but it's really, look up at that picture on the screen. It's an array where what's in each box is another array. And by convention, you could turn that picture 90 degrees, but by convention it's drawn that way because that keeps the RC Cola row then column thing going on. So technically, if nums was a two-dimensional array, and you said nums bracket 0, technically what that is that's one array. So nums bracket 0 is one array, whereas nums bracket 0 bracket 2 is one element of that row. You don't need to know that all that much, but it does come up. There's one specific thing where you have to think about why that is important. And that actually comes up on the next slide. So we got a lot of practice last semester looping through a one-dimensional array, a plain old array. So I want to take you through an example here, and this is kind of a pattern where you're going to loop through a two-dimensional array. Looping through a one-dimensional array over and over again, we did a for loop, for int I equals 0, I is less than nums.length, I++. Probably wrote that dozens of times last semester. Well, now when you're looping through a two-dimensional array, it basically takes two different for loops. One to loop through the rows, one to loop through the columns, and we nest them. And if you think about it, if you loop through all the rows, and then within each row you loop through all the columns, you'll hit every single element. Okay? So because the usual convention is to use R and C rather than the letter I, because it just helps you keep track that R is which row you're on and C is which column you're on. You can use I and J if you want, but I think that's a bad idea because then you get mixed up. Wait, is I the rows or is J the columns? If you use R and C, you'll always know. Okay, so look at the kind of first for loop where I put something in bold. R is less than nums.length. On the previous slide, I taught you that nums as a two-dimensional array is really an array of arrays. So nums.length is the length of that original array. I'm going to just swing back one slide here. Nums is the original array, which is basically how many rows it is. Okay? Now think about this. The next line where it says C is less than nums bracket 0.length. What is nums bracket 0? Well, again, on the previous page, I taught you that nums bracket 0 is one individual one-dimensional array. So nums bracket 0 dot length is the length of that array, which is the number of columns in the two-dimensional array. Again, go back, think about nums bracket 0 there. That's an array. And the length of that top array that goes 0, 0, 0, 0, the length of that is the number of columns in the whole two-dimensional array. You'll get used to thinking that nums.length for a two-dimensional array is the number of rows. Nums bracket 0.length is the number of columns. By the way, you could put nums bracket r.length. You could put nums bracket 1.length. We're going to assume that it's a square, or it's not square, it's a rectangular grid. So all the rows have the same length because it's a rectangle. And then the third thing in bold where I put nums bracket r bracket c, that's the rth row and the cth column. So this is kind of a very typical pattern you'll see. Kind of last time where we had that, last semester we had that for loop, for int I equals 0, I is less than whatever dot length, I plus plus, and then somewhere we said nums bracket I. Well, that was the pattern for a one-dimensional array. This is the pattern for a two-dimensional array. So the things you need to know are the three things in bold. Nums.length is the number of rows. Nums bracket 0.length is always the number of columns. And then nums bracket r bracket c is a useful thing where if you nest those two for loops, then you'll hit every single element in every single row and every single column. So what this code does is it just declares the variable total and adds up every element in the entire two-dimensional array. In the next few slides, you'll see follow this pattern to do slight different variants on it, just like we used to do slight different variants on the looping through a one-dimensional array. So this one, look, I declare a two-dimensional array at the top called nums. It's a two-dimensional array that's 10 by 10. Then I have a for loop going from r is less than nums.length. Nums.length would be 10. Remember, nums.length is the number of rows. Then inside that I have a for loop saying c is less than nums bracket 0.length. Nums bracket 0.length is the number of columns. Just memorize that. Nums bracket 0 is the number of columns. And then what I say here is nums bracket r bracket c. That's the, it's kind of like the ith element, only it's the rcth element. It's the element in row r, column c. Then I wrote equals r times c. If you think about that for a second, what this will do is it'll actually make your standard multiplication table. Because like what's in row number index 4, column index 7 would be the number 28. Okay, it's a little bit missing because you're going to have zeros on the side because you started at 0, not at 1. This would actually get you the multiplication table for the zeros through 9s. Okay. This next one is a very similar thing. You've probably seen this lots of times before. This is our who has the championship belt algorithm. This is finding the smallest thing in a two-dimensional array. So we start with the first one. So int smallest equals nums bracket 0 bracket 0. That's the first one, the one in the upper left-hand corner at row 0, column 0. Then we do these two nested for loops. Again, nums.length is the number of rows. Nums bracket 0.length is the number of columns. And then I say if nums bracket r bracket c, that's the rcth element, is less than smallest, then hooray, we have a new grand champion smallest. And then I say smallest equals that element. See how it's very similar to the algorithm you would use to find the smallest thing in a one-dimensional array, except basically we just have two nested for loops and kind of replace in your mind the idea of nums bracket I with nums bracket r bracket c, and then essentially the logic is exactly the same. By the way, I'm looping through the array rows first, then columns. You could go the other way, but I think that kind of messes up your RC colla, so just do it this way every single time. You'll be fine. Just wanted to show you here I'm pretending I have some two-dimensional array of strings called words. That would be string bracket 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 words. So now I'm looping through the two-dimensional array of strings. The goal of this code is to count up the number of words that begin with the letter C. So again, there's my words.length, that's the number of rows. Then words bracket 0.length, that's the number of columns. Then look at this next line. Words is a two-dimensional array of strings. Words bracket r bracket c is one string. Then I can say dot substring 0, 1 gets me a string that is the first letter. Then I can see if that letter equals a C. So it's a fun line. Words bracket R bracket C dot substring 0, 1 dot equals bracket or dot equals C. Then I just counts up the number of words anywhere in the grid, anywhere in the two-dimensional array that began with the letter C. Okay, a couple just kind of frequently asked questions that always come up when I talk about two-dimensional arrays. I thought I would just answer them right now. The question is, can you make a two-dimensional array not of just arrays, but instead of array lists? Maybe you want it to grow and shrink. The answer is yes, you could. You can make it essentially an array list of array lists, but I've never seen it done because it turns out usually by kind of just this kinds of problems you want to solve with two-dimensional arrays, almost always you know how big the two-dimensional array is. You know the number of rows and columns ahead of time. Maybe it's because it's a graphic or a game board or something like that. I've actually never seen a specific situation where you need to make an array list of array lists, although I guess in theory you could. You could look it up. I'm sure it's been done at some point. I'm sure there's some crazy reason why you might. I've never personally had to do that myself. So we won't do it at all. We'll only just stick to arrays of arrays, not array lists of array lists. The next question is, since a two-dimensional array is just an array of arrays, can the rows be different lengths? In other words, could the first row have 5 elements and the second row have 7 elements? So it's kind of not rectangular, but it's sort of jagged, okay, where all the rows have different lengths. The answer is yeah, you can do that. It actually has a name. It's called a jagged two-dimensional array. You'll probably never need to do that in this class. I've done it once or twice in kind of my life. The problem is actually declaring it ends up being much more difficult. And it's not on the AP exam, won't be on our test or anything. You can assume that we talk about two-dimensional arrays. They're in the shape of a rectangle. Okay, not like the different rows will not have different lengths. Which is why, by the way, when I say like nums bracket 0 dot length, we can assume that that's the same thing as nums bracket 1 dot length, whatever, all the rows have the same length, so it's just nicest to say nums bracket 0 because it's not jagged. I'm sure like Sandy's probably thinking about this. Ooh, hey Mo, you just taught me about two-dimensional arrays. Could I also talk about like three-dimensional arrays? Or oh my gosh, how about four-dimensional arrays? You know, could you just have an array of arrays, right? Or maybe like a two-dimensional array where in each box is an array. Or like a one-dimensional array where in each box is a two-dimensional array. Or like a two-dimensional array of two-dimensional arrays. Oh my gosh, it's so exciting. The answer is, oh my gosh, yes you can. But in this class, we're going to stick to two-dimensional arrays. If you want to go crazy, Sandy, the syntax is not much harder. You just add an extra bracket. So int bracket, 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 bracket. This essentially would be a cube, sort of ints with, 5 in one dimension, 4 in another dimension, and 10 in like the height or something like that. We'll never do that in this class ever. We're going to stick to rectangular two-dimensional arrays. But nothing in the syntax prevents you from doing it. If you really want to understand the fourth dimension, kind of this might help you, but let's just move on. Okay. Just right near the end here, but I want to mention sometimes actually you only want to loop through like one row, and in that case, you actually don't need nested for loops. So the purpose of this code is basically you've got a two-dimensional array of numbers. Is the sum of all the numbers in the top row more than the sum of all the numbers in the bottom row? So notice now we're just looping through the top row and the bottom row. We're not looping through the entire two-dimensional array, so we don't need two for loops at all. So I declare two local variables called top row sum and bottom row sum, set them to be 0. If you think about it, if you loop through just one row, the row you're on stays constant, and which column you're in is what's changing. If you just think about the top row as a one-dimensional array, you're just looping through the top row, so which row you're in is always going to be row 0, and which column you're in is going to change. So I say top row sum plus equals nums bracket 0 bracket c. So notice my for loop, I don't even have an r for loop. I'm just looping through the columns. And remember, the number of columns is nums bracket 0 dot length. So look at that first line. Nums bracket 0 means I'm always in row number 0. That's the top row. And then C is changing which column, so I'm going to go to 0, 0, then 0, 1, then 0, 2, then 0, 3, then 0, 4. And that's going to get me all the elements in the top row. And I add them all together, and they'll end up being top row sum will be the sum of all the things in the top row. Similarly, the bottom row sum plus equals nums bracket nums dot length minus 1. Remember that nums dot length is the number of rows. Because we start at 0, if there's 10 rows, the bottom row would be row index number 9. So let's say nums.length is 10, nums.length minus 1 would be 9. The bottom row would be number 9. And then similarly that bracket C, so it's going to be the first, a C going through the number of columns, like 9, 0, 9, 1, 9, 2, and so on. And then we just return which of those numbers is bigger. Just wanted you to see this. If you're just looping through one row or one column, probably nested for loops is not what you need. Although the majority of time you're working with a two-dimensional array, you'll be looping through the entire grid, so the nested for loop RC coll thing is the way to go. Okay, so I want you to practice this a little bit. So for the rest of class today, there's some problems on Schoology, all involving two-dimensional arrays. Again, tomorrow will be your first guest lecturer who's going to take you through a big two-dimensional array example in BlueJ. So for right now, I want you just to practice writing out some two-dimensional array stuff on paper. So why don't you grab a partner, bring up those couple problems on Schoology, and I want you and your partner to just work on writing out the solutions to those problems. They're kind of like test-like questions involving two-dimensional arrays, although a little bit easier than ones you would see on a test, because we just learned them right now. There's a solution key up on Schoology, so you can check your answers either with your partner or with the solution key. Again, your homework tonight, you guys, is to kind of the continuing two-week homework of looking at the multiple choice questions that are posted up on Schoology. So for the remainder of class, grab a partner or maybe a group of 3, get out a sheet of paper, grab those problems on Schoology, and see if you can kind of work with your partner to help understand two-dimensional arrays a little bit. And tomorrow you'll have your first guest lecture. I'm taking you through a big, cool, lengthy 2D array example. And welcome back, you guys. Great job.